Assembly for measuring distance using ultrasonic sensor. Components required: node MCU, voltage regulator, ultrasonic sensor, 9-volt battery, battery snapper, breadboard, and a USB cable. First of all, we will take the ultrasonic sensor. The ultrasonic sensor has 4 pins: VCC, trigger, echo, and ground. Place the ultrasonic sensor on the breadboard in this way. Then we will take some male to female jumper wire. First we will connect the trigger pin of the ultrasonic sensor to pin D1 of the node MCU. Then we will connect the echo pin of the ultrasonic sensor to pin D2 of the node MCU. Then connect the VCC pin to pin AU of the node MCU. And the ground to the ground pin of the node MCU. Now if I want to power the node MCU through battery, then I will use the voltage regulator. Place the voltage regulator on the breadboard. Then take a battery snapper, connect the red wire, that is the positive, to the V-in pin, and the black wire, that is the negative, to the ground pin. Take 2 jumper wires, connect the ground pin of the voltage regulator to the ground pin of one of the ground pin of the node MCU, and connect the V out pin of the voltage regulator to the V in pin of the node MCU. So this is done, but if we don't want to power it from the battery, we can directly power it through our laptop. For that, we don't need the V in and the ground pin from the voltage regulator. Remove it. Take the USB cable, connect it to the laptop and then to the node MCU. The node MCU should be connected to the laptop for the entire process. Thank you.
After doing the hardware connection for the distance measurement, now we will make the template in the Blink website. So first of all, in the Blink dashboard, click on the developer zone, and here under my templates, click on new template, and in the name you can give distance, and select the hardware as ESP8266, connection type as Wi-Fi, and then click on done. So once your template is created, now go to the data stream, click on new data stream, select virtual pin, give the name as distance, and then select the virtual pin V0, data type is integer, minimum value 0, maximum value you can give 500, and then click on create. So your data stream is created, and now we will go to the web dashboard. Here from the widget box, we will select the gauge, drag it to the dashboard, click on the setting option, then from choose a data stream, select the distance V0, and then click on save. Template is completed, and now you can click on save. So you can see your template is here. Now we will click on devices, click on new device, choose from template, choose the required template, that is distance, and then click on create. You have got the template ID, template name, and the auth token that we will require in the code. Click on copy to clipboard, and now when you will click on device, you will be able to see the device for distance. So this is all about the Blink configuration, and now we will do the Blink mobile configuration.
Mobile configuration for measuring distance using ultrasonic sensor. First of all, open the Blink IoT app. We can see the measuring distance template here. Click on the template, then click on the setting, click on the plus symbol, and select the gauge. Click on the gauge now, choose the data stream, as measuring distance V5. It's showing on the screen of the template. Thank you.
So now we will do the coding for the distance measurement. So here is the code. The first lines that we are writing a blink template ID and the blink template name we get from the device, and these lines define the template ID and the name from the blink app, and then we have given the blink print serial, and then we have included the ESP8266 Wi-Fi and the blink simple ESP8266 library for connecting the node MCU to the Wi-Fi and to the blink cloud. Here we have assigned the trigger to pin D1 and the echo name to pin D2, and then we have given the token that we have got from the device, blink device, then Wi-Fi name, Wi-Fi password. In the void setup, we have initialized the serial monitor using the baud rate 9600. We have given blink.begin with the token, Wi-Fi name and Wi-Fi password to connect the node MCU to the Wi-Fi and blink server. And then we have used the pin mode function to set the trigger pin as output and echo pin as input. Now in the void loop, first we have created two variables, duration and distance, with the data type as long. Duration will store the time sound took to return, and distance will calculate the distance in centimeter. So this line is used to send a 10 microsecond high pulse to the trigger pin. Then the pulse in function waits until the echo pin goes high and then low and measures the duration. This duration corresponds to the time the pulse took to return. Then here the duration is converted to distance by multiplying it with the 0.034, which is the speed of sound, and it is divided by 2 because the sound travels to the object and back, so we have divided so that we can get only one way distance, and we have stored the value in the distance variable. Then we have used the serial.print to print the distance in the serial monitor, and then we have written blink.virtual write v0, distance. This sends the distance value to the virtual pin v0 in the blink app, so that we can check the distance value in the blink website or the blink mobile app. And also we have given a short delay for the readings, and then lastly we have written blink.run it to keep the connection between the node MCU and the blink server alive. After the coding is done, we will click on tools, go to boards, and under the boards, under ESP8266 board, we will select either node MCU 0.9 or node MCU 1.0, and then again click on tools. From the port, select the desired comp and then click on upload. Your code will be uploaded to the node MCU.
Output of measuring distance using ultrasonic sensor. First of all, open the blink app. You can see the measuring distance template here. Click here. So here we can see the distance of the object in front of the ultrasonic sensor. So now I will keep the phone here. And as you can see, since there is no object in front of the ultrasonic sensor, the distance is increasing. Now as soon as I place an obstacle in front of the ultrasonic sensor, its distance decreases. It is showing that the distance of the object in front of it. But if I keep the object a little far, the distance increases. Similarly, we can see the same thing on the website. So, if I bring the object near the ultrasonic sensor, the distance decreases, and if I place it a little far, the distance increases. Thank you.